So this is one of the questions from the practice quiz that I do get some questions about. And what we've got here is some extra information, and this is what I'm talking about over here. So all of this here, this information here, this is given to you in the instructions, and it represents all the different kinds of series that are possible, at least for this question. So let's look at what I mean by a series. So when we start with an atom, and I'll just go ahead and put some energy levels here. And I've gone ahead and put in 4 here. So let's say we've got an electron here. If we're talking about the n equals 1 Lyman series, see, this is n equals 1 down here. This is n equals 2. This is n equals 3. And this here would be n equals 4. What we're talking about here is a transition from 4 down to 1, or from 3 again down to 1, or from 2 again down to 1. So what we're talking about here is the end of the series, so where the transition ends up here. So that would be the Lyman series right there. Anything that ends in n equals 2 would be the Balmer series. Anything that ends in n equals 3 would be the Paschen series. So effectively what you've got, if I'm telling you that a line is a member of the Lyman series, that means you already have one of the n values, and you know that it's going to be 1. And the names here will tell you what the n value will be if it's not n equals 1. Okay, so let's take a look at how you might solve a problem like this. What you're given here is a wavelength. Now there's 3 equations that we're using here to make this work. So we've got E equals 2.179 times 10 to the negative 18. It's a new tablet, so I'm still getting used to it here. And that's joules, and it's 1 over n1 squared minus 1 over n2 squared. So that's one of them. The other equation that we'll use will be E equals h nu, and then we've got C equals mu lambda. Now what we know is that lambda is wavelength. And then we've got nu here, that's going to be frequency. Now c here is the speed of light, which we're also given up here as well. So what we are initially given is the wavelength, but it's in nanometers. So if we're starting out with 91.8 nanometers, what we're going to have to do is convert that into meters. Now we're using a conversion factor here, and that is that 1 nanometer is equal to 10 to the negative 9 meters. So that should be your first step, is to convert nanometers into meters. And then we're going to need the frequency. So that's going to give you that will end up giving you the wavelength. Then we need the frequency. So the frequency, which is going to be nu, is going to equal C divided by lambda. Now the lambda is this value down here, and c is going to be this value here, the speed of light. And then after you've gotten nu, then we need energy. And energy is equal to h times nu. Now nu is what we just got from over here. And h is Planck's constant, which is up here. And once we've got energy, then we can apply this equation. E equals 2.179 times 10 to the negative 18 joules 1 over n1 squared minus 1 over n2 squared. Now we already know what the value of one of these is, because we know that n equals 1, because we're told that it's a member of the Lyman series. Which one? It doesn't really matter, but we'll just go ahead and we'll make it this one here, n1. So that's going to be 1. And what you'll effectively be doing is solving for n2 squared, which is down here. And then you'll need to do a bit of algebra to do that. The energy is going to come from over here, because that's what you solved for in the previous step.